Hello, everyone. Come to us and ask all the questions that people need to know. Imagine looking up at the night sky from Earth, seeing countless stars sprinkled against a backdrop of endless darkness. These pinpricks of light have fascinated humanity for millennia, and their story is one of cosmic grandeur and awe-inspiring scale. To truly understand stars, and to appreciate the giants among them, let's start with the basics, right here at home. Earth orbits the Sun, our planet's very own star, which dominates the solar system with almost all of its mass and energy. But not every massive object out there is a true star. Take gas giants like Jupiter. With a mass about 11 times that of Earth and 375 times as much weight, Jupiter seems colossal. Structurally, it even shares similarities to our Sun, but it falls short of stardom. It simply doesn't have enough mass to ignite the nuclear fusion that defines stars. That brings us to brown dwarfs, sometimes called failed stars. These objects sit in the gray zone between planets and stars. Brown dwarfs are typically between 13 and 90 times the mass of Jupiter. Add more mass to them, you might think they'd just get bigger, but instead they become denser. Until eventually, the pressures at their core allow for some limited fusion, glowing dimly in the void. Yet they still don't achieve true stardom. Brown dwarfs are the missed opportunities of the cosmos, never quite massive enough to shine as true stars. But what does it take to become a real star? The magic starts when a sphere of gas gathers enough mass that its core ignites hydrogen fusion, turning hydrogen into helium and releasing vast amounts of energy. This is the birth of a main sequence star. These stars strike a delicate balance. The inward pull of gravity tries to crush them, while the outward pressure from fusion pushes back. The more massive a star, the hotter it burns, the brighter it glows, and paradoxically, the shorter its life. The smallest bona fide stars are red dwarfs, just heavy enough to start fusing hydrogen. With a mass around 100 times that of Jupiter, they glow faintly in shades of red, operating like cosmic embers. Red dwarfs are the most numerous stars in the universe. Because they burn their fuel so slowly, they live for trillions of years, far longer than the universe has even existed so far. They fade quietly, never ballooning into giants or detonating in supernova. Slightly more massive stars, like our Sun, inhabit the middle ground. It blazes much hotter and brighter than red dwarfs, but with increased brilliance comes decreased longevity. The Sun's lifetime is a relatively modest 10 billion years. It's only about 7 times the mass of a small red dwarf, yet shines 300 times brighter. And it's vastly outshone by even more massive stars. For example, Sirius, the brightest star visible from Earth, is twice as massive as the Sun and nearly 25 times brighter. Its lifetime, though, is a fraction of the Sun's, a few billion years at best. Push the limits further, and things get wild. Stars with 10 times the Sun's mass can blaze at surface temperatures of 25,000 degrees Celsius, throwing off tens of thousands of times more energy than our Sun. But such radiance comes at a cost. These enormous stars exhaust their hydrogen in mere millions of years. A cosmic blink. The rarest, most massive of these, like R136A1 and the Tarantula Nebula, are around 315 times the Sun's mass, and shine with unimaginable intensity, millions of times brighter than our own star. Yet even these titanic stars lose mass constantly, their powerful stellar winds hurling billions of tons of material into space every second. They live fast, die young, and change the very chemistry of the galaxies they inhabit. But does bigger always mean more massive? Not necessarily. As main sequence stars reach the end of hydrogen fusion, they swell into giants, their outer layers expanding outward while their cores contract. The red giant Gacrux, for instance, is only about 1/3 the Sun's mass, but its radius has already swollen to 84 times that of our star. Our Sun will eventually become a red giant as well, ballooning as far as the orbit of Earth or even Mars before shedding its outer layers in a planetary nebula. The most massive stars undergo even more dramatic transformations. After burning through hydrogen, they go through a series of fusion stages, becoming supergiants and then hypergiants. These monsters, like the blue hypergiant Pistol Star or the yellow hypergiant Rho Cassiopeiae, can reach radii hundreds of times greater than the Sun and shine with hundreds of thousands of times its luminosity. Some, like Rho Cassiopeiae, are visible across thousands of light-years, earning their place among the true behemoths of the galaxy. So, which star is the true giant of the universe? The current record holder for sheer size is believed to be the red hypergiant Stephenson 218, at once remote, rare, and staggering in scale. With a radius roughly 2,150 times that of the Sun, it is so vast that if you placed our Sun where Stephenson 2218 sits, its surface would easily engulf Saturn's orbit. If light itself were to travel from one end of Stephenson 218 to the other, it would take nearly 9 hours. A mind-bending concept, given that light takes just over 8 minutes to journey from the Sun to Earth. Yet even these titanic stars are temporary. As red hypergiants approach the end of their lives, they shed enormous amounts of material through stellar winds before dying spectacular deaths in supernova explosions. These cataclysmic events enrich the galaxy with elements needed for new stars and planets, recycling cosmic material and keeping the cycle of creation alive. In the grand cosmic dance, from faint red dwarfs to hypergiant titans, stars live, evolve, and die, weaving patterns of creation and destruction across billions of years. Their births illuminate nurseries in swirling nebulae. Their deaths seed the cosmos with the stuff from which worlds and life are built. Whenever you look up at those distant lights, you're witnessing not just the present, but echoes of the universe's long, ongoing story, written in starlight across the darkness.